Okay. So is this the endo or the exo product?
Endo.
Because this is pointing opposite to where this inside substituent was, and this is the exo. So actually, if they told you to draw the endo products, you'd want to draw both of these. And if they asked for the exo product, you'd want to draw both of these. And if they asked for all the products, there would be 4. We mentioned that there's a possibility sometimes to get up to 4 or more products, so here would be a case with a whole mess of products.
Oh, because
and these are all different from each other.
Oh,
Pardon?
that's so annoying. So even if like they drew it down, we still have to think that way if it's like facing up. Like we would have to draw the 4 products even with the equation.
There's no real meaning to the way they draw the dienophile. You still need to imagine it rotating it in itself in all different directions. There isn't actually any meaning to the way they've drawn this, because in the solution is constantly rotating all over the place. So this is a whole new issue we never talked about before. You have to consider, sometimes there's a difference between whether the dienophile is oriented up or down vertically, so to speak. You have to consider what happens if the substituent starts pointing down like it does here, or what happens when it starts by pointing up. This happens, you get the hang of this by just doing a bunch of problems and seeing this come up. It's kind of a pain to figure out who the endo and the exo products are. You can use this little approach here, right? So the endo, if a substituent starts endo, it should end up in the same place as the outside, and if it starts exo, it should end up in the same place as the inside. But how does that apply to a cyclic diene? Well, it does in a sense. So let's lay that out. Notice that when we draw the cyclic dienes, we always draw the inside substituent pointing up. That's just the convention. When we draw a cyclic diene, we always draw the inside substituent pointing up. Now, it's perfectly logical to have drawn this pointing down, but you'll notice that you've never seen a picture like that. It's just not conventional to draw the tent pole pointing down. All the pictures we draw pointing up. That means that the inside substituent is always going to end up pointing up when we start with a cyclic diene. So where would an endo substituent end up?
Down.
Down. So that's our little rule of thumb. For cyclic dienes, the endo approach always puts the substituent down. For cyclic dienes, the endo approach always puts the substituent down. Now this is only for cyclic dienes. That doesn't apply to the non-cyclic dienes that we saw before. Because for non-cyclic dienes, you could put the inside substituent on a wedge or a dash, either up or down. But when we draw cyclic dienes, it's just a convention to always draw the tent pole up. Well, then the endo substituent would always end up down. And I find that's a much easier way to see who's endo or exo. Here the substituent is down, so it's endo. Here the substituent is up, so it's exo. Here the substituent is down, so it's endo, and here it's up. And just as a little memory aid, notice that endo ends with the letters DO, which happens to be the first 2 letters of the word down. So as a memory aid, that helps us to remember that when we had started with a cyclic diene, the endo substituent ends up pointing down. That's only for the cyclic diene. So that's a little shortcut. So there was a lot involved in that case. Okay? Okay. Let's draw all the possible products here. I want to draw all possible products. That's right, no free rotation around a double bond. These two substituents are in similar positions to each other on the dienophile, and there's no free rotation around this. So these should end up in similar positions in the product. These two
It's
should.
not like the other one where you can just draw it like in different ways.
That's right. Well, so there, if you wanted to, you could draw this
Okay.
like this, because that would just be flipping it. But you can't actually rotate so that it goes from cis to trans. So there is no, so it's perfectly allowable to flip the whole molecule. You can flip the whole molecule, but you can't simply rotate one substituent while leaving the other substituent in the same place. There's no free rotation around double bonds. Yeah, I didn't make that clear in the previous cases. Maybe it hasn't been clear what rotations are permissible and what aren't. But I think we've seen just even last term that you can't take something that's cis around a double bond and turn it into trans. That type of flipping and rotating doesn't happen. So since these started out cis, they should end up cis. So they should either both be pointing up or they should both be pointing down. So here I have them both pointing up and here I have them both pointing down. And one of the main tricks I was putting in here was to see whether you guys could handle a six-membered cyclic diene, but that didn't give you any trouble. You just had kind of a bigger tent. You kind of had a tent with two poles or whatever over here. Maybe it helps to number these here so we can keep track of what's going on, but that didn't seem to give you any trouble. These are still the dots and these are still the asterisks.
Isn't there only one product though?
You're saying these are the same?
Mm-hmm. Is it a meso?
I don't think that these compounds will ever be meso.
Why not?
That's a good question. Why not?
Isn't there a plane of symmetry in the middle of the...
Well, first of all, I think it's plain that there's no way to rotate this to look like this. For example, if you just turned it upside down so that the up things would point down, then the tent pole wouldn't be pointing in the same direction. Now, one thing we don't need to worry about is we don't need to worry about the vertical orientation here. We don't need to worry about flipping this vertically because we have the same substituent on both the top and the bottom. So there really are only two products here. Is this the endo or the exo product? And this is endo. Yeah, and for me, the easiest way to see that is, oh, do means down. If you start with the cyclic diene. Since we started with the cyclic diene, do means down. Well, here's the case where these were pointing down. So this is the endo and this is the exo.